Good afternoon. We are now moving on to our third method of solving quadratics. The first two were factoring and square root. So now we're up to completing the square. And I have a little visual here to help you understand what we're doing. So think of this method as literally and physically completing a square by inserting a little tiny square and attaching it to this nearly perfect square that's missing its corner. So we are looking for that piece to complete this larger square. And that little piece that we're inserting here is itself a square, a smaller square. And there's one thing I want you to remember from last time when we talked about solving by square root. I want you to keep in mind that if we have something squared equaling something else, we can always take the square root of both sides to get a equals plus or minus square root of b. But I want to emphasize that this a is not always a variable, is not always a single variable. This a, I use a because it stands for anything, and I really mean anything. This could be anything. So anything squared, if anything squared equals b, then that anything is equal to plus or minus rad b. And that anything may or may not be a single variable. It could be a binomial. It could be even be a trinomial. It could be anything. Okay, now back to this literally and physically completing a square. We're going to do a little exercise called missing piece. So I have a binomial x squared plus 6x, but I want this binomial to be a trinomial, and not just any trinomial. I want it to be a perfect square trinomial, perfect square trinomial. So my question to you is, what is the value that goes in that box to make this trinomial a perfect square trinomial? Well, if you think about it, a few seconds, maybe a few minutes, you'll eventually see that it needs to be a 9. If it's a 9, then this perfect square trinomial is x plus 3 squared. Here's another example. X squared minus 10x plus blank is a perfect square trinomial. What goes in the blank? Think about it some more, try some numbers, a little guess and check, and you will arrive at that missing ingredient needs to be 25. This is what we are doing here. When I put a 9 in that box, what I'm doing is saying I need a value of 9 in that corner to make this a perfect square. Without that 9, this is not a perfect square. It's just a binomial that you could factor, but it's not a perfect square. Without this 25, this is not a perfect square. But with the 25, it is a perfect square, and it can be factored as such. Okay. Now, these first two examples I sort of did by guess and check, but you need a method. You need some sort of method to find that number, because your trinomials are not always going to have nice numbers, like a b of 6 and a b of negative 10, and a c of 9 and a c of 25. So what is the systematic way of getting that 9 without guessing and trying? Well, we have to remember the pattern for a perfect square trinomial. It's a squared plus 2ab plus b squared. And the factored form of that is a plus b times a plus b. I'll just write it as a plus b squared. Okay, so in the missing piece exercise, we don't have the b squared. We just have a squared plus 2ab. The b squared is not there yet. We're trying to find the b squared. Okay, to find the b squared, it would help to know what b is, right? Well, luckily, b is located in my middle term. The b for this trinomial is located in that 6x. Okay? Now, a in the middle term, that's x. Okay? A takes the place of x. So that means that this 6 corresponds to 2b, 2 times b. Okay, if 6 is 2b, then I can solve for b. b must be 6 divided by 2. So from this 6, if I divide this by 2, I find out that b is 3. And then I square the 3 and get my missing little square to complete this perfect square. I'll repeat that again. You take your b, you divide it by 2, then square it, and you get that missing value that completes the square. Once you complete the square, you just factor the perfect square trinomial. It works here too. Here's my b. It's negative 10. I divide that by 2. Or, sorry, I should have said c, not b. I divide 6 by 2 and I get c equals 3. I divide negative 10 by 2, I get negative 5. I square that, and I get my missing number, 25. Completes the perfect square. I factor the perfect square trinomial. Let's do it one more time. I take negative 4, I divide by 2, get negative 2, I square it, and I need a 4 there to complete the square. And then I can factor it. Okay, this is the action. This is the action of completing the square. However, it's not the only action that you have to do in the whole solving process. This is just the culminating action. You have to do other stuff as well based on what kind of equation is given to you. So you may get an equation that looks like this. And you might be instructed to solve by completing the square. I'll just put CTS. Solve by completing the square. Okay, so remember, we need this number to be a certain number to complete this perfect square trinomial. 4 is not the right number. So we got to figure out what is the number supposed to be. We do that by going here and doing what we just did up here 3 times in a row. We take negative 6 divided by 2, and then we square this. And we get 9. But this number isn't 9. Okay, I need it to be 9. So I got to add something to it, right? 4 is less than 9. So what I will do is simply add 5 to both sides of the equation to make that 9. I have to add it to the right to make it legal, OPE. Now, the left side has a perfect square trinomial, and the right side has a 5. You don't have to worry about it. We're not factoring, so this doesn't have to be 0. Now I factor the left, whoops, x minus 3 squared equals 5. Oh, I just said we weren't factoring. We are factoring. Okay, now we're at the step that I alluded to at the beginning. Remember, when you have something squared equals something, you take the square root of both sides. And don't forget that plus or minus. That's what I have here. I have something squared equals something. That's my signal. Take the square root of both sides. I'll actually draw a square root. Okay, square root of x minus 3 squared is x minus 3. Don't forget the plus or minus. Square root of 5. Now 5 is prime, so there's nothing else I can do with the square root of 5. It's done. But I do still have to isolate the x. That's simple. I just add 3 to both sides. X is 3 plus or minus rad 5. Okay, that was a very long, drawn-out process. It involves a lot of stuff. Dividing, squaring, adding something to both sides, factoring, taking the square root, and then tidying up at the end. It's a lot of stuff. So you need to take it slow if you're doing this for the first time. Okay? Okay, so this situation was a trinomial that wasn't a perfect square, and the other side is 0. Now here's a slightly different situation. Again, we have a trinomial, but this time the other side is not 0. Okay, first thing we need to do is we need to figure out what is this number supposed to be to make this a perfect square. I go back to the middle term, I locate my b, I divide by 2, and then I square it. That number needs to be 49. It's a negative 8 right now. Okay, what I'm going to do first is get rid of this minus 8 by adding 8 to both sides. Okay, now I have space for that third term. I need it to be 49, so I will add 49 to both sides, making the right side 60. Now my square is complete. I can factor it. I have something squared equals something, so I can take the square root of both sides. Don't forget the plus or minus. Okay, I'm going to go ahead and subtract 7. And I notice that 60 looks like a number that might simplify out of the rad, because 60 is 4 times 15. So that's perfect square. That means a 2 can come out. And there you have it. Okay, this one was slightly longer than the other one because I was able to simplify the number in the rad. And also, I started out with this minus 8 that I got rid of in the first step. So that added 2 steps that I didn't have to do the first time. Okay, in this situation, I have a binomial that equals a non-zero number. This shouldn't be scary. It's actually the same type of situation that you had here. and you could even argue it's the same as what you had in the first example. I still need a missing number here. I take my 8, divide by 2, I square it, I get 16. So I need a 16 there, a plus 16 there. So I will add 16 to both sides. Don't forget to add it to the right. 23. Factor to the left. Take the square root of both sides, plus or minus. Get rid of that 4. And you are done. Okay, if you want to pause at any moment, go ahead to review any of this stuff. Right now, I'm going to show you a different kind of trinomial, because all of these trinomials had something in common. A was 1. But we know trinomials don't always have a equals 1. What if a is not 1? Do I do it the same way? Well, yes and no. Yes and no. Okay, here's an example where a is not 1. Actually, I think I'm going to change this to a 2 for this example. Okay, a is not 1. What I didn't tell you before is this process of sticking the missing piece in here only works if a equals 1. In all of these, a equals 1. So you are allowed to just worry about b, taking half of it, squaring it, and putting that squared number there. It only works when a is 1. Here, a doesn't equal 1. So does that mean you can't solve this by completing the square? No, you still can. But you have to prep this equation. You got to make sure that a is 1 before you start doing all these steps that we just did. So I will divide everything in the equation by 2. Okay, now I can proceed as normal. Now I may do what I did here, what I did here, and what I did in the first example. I take half of this -4, it's -2. I square it, I get 4. So this number needs to be a 4, not a 1. Okay, easiest way to do that is, since it's 1, and 1 is 3 away from 4, I'm just going to add 3 to both sides. Okay, now that the square is complete, I can factor. I have something squared equals something, so I take the square root of both sides, not forgetting the plus or minus. And then I add 2 to isolate the x. All right? Okay, that is completing the square. You do have a worksheet, I believe, to practice this, so you can either watch this video a second time or start working on that worksheet and maybe refer back to the video if you need to. See you next time.